my students, welcome to today's class. Last class we have discussed about the arrangements of resistors in a circuit, isn't it? In today's class we have to study about the uses of heating effect of electric current. There are many devices which are working using this heating effect of electric current. Which are the examples for such devices? Electric iron box, heater, soldering iron, etc. All these devices are working using this heating effect of electric current. Then these electrical heating appliances are converting electrical energy into heat energy. Those things we have already discussed, isn't it? Then when we are analyzing these heating appliances, we can see that there is a common part in these heating appliances, that is heating coil. Heating coil is the part which is converting electrical energy into heat energy. Here heating coil is made of nichrome. Nichrome is a combination of nickel, chromium and iron. Heating coil is made up of nichrome. Nichrome is a combination of nickel, chromium and iron. Then why we are choosing this nichrome to make this heating coil? The advantages of nichrome are it is having high resistivity, high melting point and the ability to remain red hot for a long time without getting oxidized. One more time I am repeating. Nichrome having high resistivity, high melting point and ability to remain red hot for a long time without getting oxidized. That's why we are choosing nichrome for making this heating coil. Is it clear? So here heating appliances are having a common part, that is heating coil. Heating coil is converting the electrical energy into heat energy and it is made up of nichrome. Nichrome is a combination of nickel, chromium and iron. Nichrome having high resistivity, high melting point and ability to remain red hot for a long time without getting oxidized. And another device which is working using this heating effect of electric current is a safety fuse. Do you know what is safety fuse? Safety fuse is a device which protects our appliances from the danger when there is excess flow of current in the electric circuit. Safety fuse is a device which protects our appliances from the danger when there is excess current flow in the electric circuit. Here this safety fuse is working using this heating effect of electric current. Here is the picture of safety fuse. In the safety fuse, the fuse wire is a main part. This fuse wire is made of alloy of tin and lead as it's having low melting point. Fuse wire is made of alloy of tin and lead as it's having low melting point. Do you know how the fuse is working? When there is excess current flow in the circuit, the fuse wire melts and the circuit breaks. Thus our devices will be protected. When there is excess current flow in our electric circuit, the fuse wire will melt as it's having low melting point. Then the current flow in the circuit will be blocked. That is the working of fuse wire. Then how the fuse wire melts when there is excess flow of current in the circuit? Do you know which are the circumstances which causes high flow of current in a circuit? You may be heard about the terms. The situations which causes high current flow in the circuit is short circuiting and overloading. Short circuiting and overloading are the two circumstances which produces high flow of current in the circuit. When a circuit is said to be short circuited? A circuit is said to be short circuited when the positive and negative terminals of a battery or the two wires from the main comes into contact without the presence of a resistor in between them. Then the circuit is said to be short circuited. When the positive or negative terminals of a battery or the two wires from the mains comes into contact without the presence of a resistor in between them, then the circuit is said to be short circuited. It allows the high flow of current in the circuit. Then when we can say a circuit is overloaded? When the total power of the devices connected in the circuit exceeds the capacity of circuit, that time it is called overloaded. When the total power of devices which is connected in the electric circuit exceeds the limits of that circuit, that time the circuit is said to be overloaded. And the safety fuse is helping us to overcome these two situations. When there is excessive flow of current in the circuit, we know that according to Joule's law, as the current increases, the heat generation also increases. When high amount of heat is generating in the circuit, the fuse wire melts as it is having low melting point. Then the circuit breaks and the devices which are connected in the circuit will be protected. This is the working of fuse wire, or this is the working of safety fuse. Then, how we are connecting a safety fuse in a circuit? Whether it is series or parallel, we have to ensure that the safety fuse is connected in series to the circuit. What will happen that when we are connecting the fuse wire which is parallel to the circuit? When there is excess flow of current due to short circuit or overloading, the fuse wire melts, but the extra current flow through the other branches of the circuit. So there is no use in connecting the fuse wire parallel to the circuit. So don't forget that the fuse wire or the safety fuse should be connected in series to the circuit. And one more thing we have to care when we are connecting a fuse wire in a circuit is we have to choose a suitable fuse wire to every circuit. Different electronic circuits are having the capacity to flow different amount of current through it. So for each electronic circuit, we have to choose the fuse wire of proper capacity. For that, we have to study a new term, that is amperage of a fuse wire. Have you heard it earlier? That is a new term. Amperage is the ratio of power of a device to the voltage applied. Amperage is the ratio of power of a device to the voltage applied. So equation to find the amperage is equal to wattage divided by voltage. Amperage is the ratio of power of a device to the voltage applied, and the equation to find amperage is wattage divided by voltage. Wattage is the power of that equipment we are connecting in the circuit. So here, when we are connecting a fuse wire in a circuit, we have to use a fuse wire of proper amperage which is suitable to the circuit. Is it clear? So the two things we have to care when we are connecting the fuse wire in a circuit is the fuse wire should be connected in series, and we have to choose the fuse wire with proper amperage in accordance with the intensity of current which is flowing through that circuit. Is it clear? Then we know that when current is flowing in that circuit, in every time a small amount of heat is generating. That amount of heat is generating in the circuit is transmitting to the surroundings. But when there is an excess flow of current only, excess amount of heat will produce, and that time only the fuse wire will melt. Is it clear? When there is an excess amount of heat is generating in the circuit due to the excess current flow in the circuit, that time itself the fuse wire will melt and our circuit will be protected from the danger. This is the working of fuse wire in a circuit. So safety fuse is a device which protects a circuit from the danger when there is excess flow of current in the circuit due to short circuit and overload. Is it clear? So that's all about the uses of heating effect of electric current. Then let's move on to the next topic, that is the electric power. Have you heard about electric power earlier? We have already studied about electric power in earlier classes. Power is the ability to do work or the work done in unit time. Otherwise, power of an electric appliance is the total energy consumed by it in unit time. The power of an electric appliance is the total amount of energy consumed by it in unit time. Those things we have already studied in earlier classes. So here, power, here, equation to find power is work done by time, and the unit of power is watt. What is the unit of power? Watt itself. Then we have to find equations to calculate power of a device. We know that there are three equations to find the heat generated in a circuit using Ohm's law. Those equations are H is equal to I square RT. All of you say with me, which are the three equations to calculate the heat generating in a circuit? H is equal to I square RT, H is equal to VIT, and H is equal to V square by R into T. We can obtain the equation of power from these equations of heat itself. When we are removing the term of T from these three equations, we can obtain the equation of power, as the power is equal to W by T. Both the T's will be cancelled together. Then we can obtain the equation of power. The three equations are P is equal to, from H is equal to I square RT, we can obtain P is equal to I square R. Here we are not considering the term T. The next equation, from H is equal to VIT, we can obtain P is equal to VI. Then here is the third equation of power. From the equation, H is equal to V square by R into T, P is equal to V square by R. These are the three equations to calculate the power of a device. Is it clear? So, power of an electric appliance is the total energy consumed by it in unit time. Then the unit of power is watt. Then the three equations of power, you have to study these three equations. P is equal to I square R, P is equal to VI, and P is equal to V square by R. So let me convert all the things we have discussed in today's class. We have started with the uses of heating effect of electric current. Then in every heating appliances, it is having a common part, that is heating coil. Heating coil is made of nichrome. Nichrome is a combination of nickel, chromium and iron. Then the advantages of nichrome. The advantages are, it is having high resistivity, high melting point, and ability to remain red hot for a long time without getting oxidized. Then we discussed about the working of safety fuse. Safety fuse is working using this heating effect of electric current. Then the two things to be ensured when we are connecting safety fuse is, safety fuse should be connected in series, and the fuse wire with proper ampere rate should be connected in accordance with the intensity of current which is flowing in that circuit. Then we discussed about short circuiting and overloading. Then we have discussed about this electric power, then the three equations of power. Rest of the things we can discuss on the further class. So that's all for today. Thank you.